Here are the 5 steps to gram conversion problems. First, you're going to write and find out what is given to you. This is what I'm going to call the given. You're going to create a conversion roadmap. We're going to write the correct conversion factors with the correct units. Make sure that all of our units cancel, leaving us with the right units that we want. And then we're going to solve and round to 2 decimal places. Before we start with practice problems, I want to draw your attention to your news you can use. You need to have this sheet of paper. In particular, you're going to be using the conversion factors that are found in this list here. You can see that there are conversions, like this is from moles to grams, and this is the conversion factor, the molar mass of the compound and 1 mole of that compound. That trend continues all the way down until the end here where it goes from moles A and moles B. We'll use both this one and these two in this video. All right, here's our first practice problem. In this reaction, sodium hydroxide reacts with hydrochloric acid to form sodium chloride and water. We're trying to figure out how many grams of sodium chloride are produced if 15 grams of sodium hydroxide reacts. So the first step is to write down what we're given. So we know that we have 15 grams of NaOH. We also know that we're finding NaCl. It isn't explicitly given, but you should know by now that the molar mass of sodium hydroxide is 39.99 grams per mole for NaOH. And then the molar mass of sodium chloride is 58.44 grams per mole of NaCl. All right, so that's all we can do for step 1. Step 2 is to create a conversion roadmap. That means we need to figure out what units we're going to and how to get there. So right now we have grams of sodium hydroxide, and that's it. So we go from grams of NaOH, and we can't go straight to grams of sodium chloride. We have to go to moles first. So we got grams of sodium hydroxide, we can convert that to moles of sodium hydroxide. Then we can convert that from moles of sodium hydroxide based on this reaction to moles of sodium chloride. And then from there, we can go to grams of sodium chloride. So that's step 2. There's our conversion roadmap. Now we need to write the correct conversion factors with the right units. So, like I said before, this is where your news you can use comes in. This is where this whole column here comes into play. So we start from grams to moles. So we need to start with 15 grams of sodium hydroxide. And we need to do that over 1. Just to make it a fraction, it's not crazy, just make it a fraction. Then we go to moles of sodium hydroxide. If we look on our news you can use, grams to moles means that we divide by the molar mass. We've already figured out the molar mass, which is 39.99 grams of sodium hydroxide per 1 mole of sodium hydroxide. Now we're going from moles of one thing to moles of another. So sodium hydroxide is A and sodium chloride is B. And if we look on our news you can use, number of moles A to number of moles B is there. So we have, and based on this reaction, these are all 1. So that means for every 1 mole of sodium hydroxide that reacts, 1 mole of sodium chloride is produced. Then from here, we can go from moles of sodium chloride to grams of sodium chloride, and when we do moles to grams, we multiply by the molar mass, which we know is 58.44 grams of NaCl for every 1 mole of NaCl. And there we go. So that is our correct conversion factors. Our next step is to make sure that all the units cancel, leaving us with our final units. So we have grams of sodium hydroxide up here that cancels to grams of sodium hydroxide down here. Moles of sodium hydroxide cancel with moles of sodium hydroxide. Moles of sodium chloride cancel with moles of sodium chloride, leaving us with grams of sodium chloride. And that means in the reaction, how many grams of sodium chloride do we need? So we have the right units. Now we need to solve and make sure that we round our units, or round our answer to 2 decimal places. So if we get our calculator, we basically multiply everything on top and then divide by everything on the bottom. So in this case, I'm going to use my parentheses. So this is 15 times 1 times 1 times 58.44 divided by 1 times 39.99 times 1 times 1. Leaving us with 21.992 grams of sodium chloride produced. And that is our answer. Okay, here's our second practice problem. So in this reaction, we're trying to figure out how much oxygen gas is consumed if 100 grams of aluminum react. The first step is to find what's given to us. We know that 100 grams of aluminum react, and we're trying to find the grams of oxygen gas. So from here, we can create a roadmap that says I'm starting with grams of Al and reacting to go to moles of Al. Then we're going to moles of O2, and then finally ending with grams of O2. Our next step is to write the conversion factors. So remember, we're using our use and use for this. So we're going to start with 100 grams of Al, and we put that over 1. Then we're going from grams to moles. You should know by now that aluminum has a molar mass of 26.98 grams per mole of aluminum. Then we're going from moles of aluminum to moles of oxygen. So that means that this is A and that's B. So then 1 mole or 4 moles of aluminum from up here. 4 moles of aluminum reacts with 3 moles of oxygen. And then we can finally go from moles to grams. And remember, 1 mole of O2 weighs 31.99 grams. Okay, so we have that. Now our next step is to make sure all our units cancel, which grams of aluminum cancels with grams of aluminum, moles of aluminum cancels with moles of aluminum, moles of oxygen with moles of oxygen, leaving us with grams of oxygen, which is what we want. So now all we have to do is calculate it. So again, we're multiplying the top and then dividing by the multiplication of the bottom. So I'm going to use my parentheses and go 100 times 1 times 3 times 31.99 divided by 26.98. Now let me put the parentheses there. 1 times 26.98 times 4 times 1 equals. And that means that we produce 88.92 grams of O2. 92 or 93 if you round with that 6. And there you have it.